Let's get started with today's webinar here. Let me first introduce myself. Um, my name is Oscar Salas. I work for TriStar. I've been working for TriStar for about almost 10 years now. I've been working with the software for about 12 years. And, I want to thank you for attending this webinar today, taking the time. I hope that you guys get something out of it. We'll have some time for some questions and answers towards the end. And if it's something that, I don't have the answer for you guys right away, then I'll do some research and I'll get back to you guys on there. So feel free to ask us any questions that you have. And we're going to get started right away here. So we're going to start with our mechanism design webinar. And again, this is what we're going to cover today. First, we're going to explain the differences between mechanism design extension and mechanism dynamics options. Then we're going to go over mechanism connections. We're going to go over how to apply servo motors, how to run the analysis, how you can export your mechanism as an animation, and also, again, we're going to have some Q&A towards the end of this session. So first of all, let's go over what the differences between MDX and MDO are. MDX is Mechanism Design Extension. That one gets included with every license of Creo Parametric. Depending on how your license is bundled, sometimes this could be a feature that you have to select that might show up separate, but should be included in every license. Sometimes it's already within your base package, so you don't have to select anything while you're doing the installation. It just automatically will give you access to this. This will allow you to apply standard connections. You can drag components around. You can create snapshots. You can use the snapshots in a drawing. You can apply motors. You can run position analysis, which is pretty much just the basic analysis, just testing your mechanism. It will allow you to export your animation as well. So that's going to be kind of the basic portion of mechanism design extension. Again, this one is included with every seat of Creo Parametric. Now we have a second license, which is called Mechanism Dynamics Option, and this is a separate license. This will give you more functionality. It will allow you to use, besides everything Mechanism Design Extension offers, it will allow you to use spring and dampers, gear connections, cam and follower connections. Then you get more analysis types. You get kinematic analysis, dynamic analysis, force balance analysis. You can also export forces into Creo Simulate. So for example, if you got a mechanism, let's talk about an engine, and you want to see what the forces acting on a connecting rod are. Your mechanism analysis will detect those forces, and it'll allow you to export those forces, and now you can run an FEA analysis on that component using your mechanism forces. So that's something that you can do within Mechanism Dynamics Option. Again, those are the two licenses that will give you the functionality of what we're going to see today. Now, as far as mechanism connections, so the workflow of creating your assembly, it's going to be pretty much the same as when you just create a regular assembly. However, you have an option, as you can see in the image that I have here. This dropdown will allow you to select a type of connection that you want to apply. I usually get asked the question, well, what's the difference between applying a mechanism connection and leaving components partially constrained? Well, when you leave components partially constrained, you can drag them around, but you don't have any control over how you use those degrees of freedom that you have. Okay, mechanism connections will give you full control of your degrees of freedom that you have within that mechanism connection. Also, a mechanism connection will know what type of references it's already looking for. Okay, so as you select the type of connection that you want to apply, the system will automatically start looking for the references, and all you got to do is just select the references that it's looking for. So we have different types of connections. For example, we have a rigid connection. This one is going to connect two components so that they don't move relative to each other. Then we have a pin connection, which will allow rotation around an axis, but it's going to constrain translation along that axis. We have a slider connection that will allow translation along an axis, but it's going to lock rotation. Then we have a cylinder connection, and this one is used in cases where you don't want to over-constrain a mechanism. We're going to see this when we get into the demo. And it pretty much allows rotation around an axis, but it doesn't constrain translation. Then we have a planar connection. This one is going to connect components so that they move in plane relative to each other. It's going to give you 2 degrees of freedom. So it's going to be the plane degrees of freedom. And it can also rotate around an axis, normal to one of those planes. Then we have a ball connection. This one is going to connect a component so that it can rotate in any direction, and it's going to give you the 3 rotational degrees of freedom. So you can have full 360 rotation on it. You have a weld connection, and this one will allow you to connect one component to another so that they don't move relative to each other. Now, the difference between a rigid connection and a weld connection is that a rigid connection, let's say, you have a housing that has 2 components to it, and they're going to be connected through a pin. So you got 2 holes. There's going to be a pin that connects those 2 components, but you don't actually want to have the pin in the assembly yet. Even though the 2 holes might not be connected to each other, you can use a rigid connection, and you can simulate that pin going through those 2 holes. So that's the rigid connection. A weld connection, of course, it's going to act as a weld. So that's the components have to be mated to each other in order for the weld to work. Then we have a bearing connection, which is a combination of a ball and a slider connection. So it's going to give you 4 degrees of freedom, right? So you have the 3 rotational degrees of freedom of the ball constraint, and then you have the translational degree of freedom of the slider constraint. A general, this one is a pretty flexible type of connection that will allow you to have 2 configurable constraints. So you pretty much control which 2 degrees of freedom you're going to have. You have another one that has 6 degrees of freedom. So pretty much as the name says, it's 6 degrees of freedom. Doesn't really constrain your component at all. But the benefit of this one is, again, you can control those degrees of freedom. That's why you get this type of connection. Even though the component might be free to move in all degrees of freedom, you can still tell it how much it's going to move, right? You can control distances, you can control rotations through it. We have a gimbal connection, which is a pivot joint with 1 center constraint. And then we have a slot connection, which is a point on a non-straight trajectory. So this one will give you 4 degrees of freedom, where the point is going to follow the trajectory in 3 directions. So those are the connection types that are available that we can use when we're creating an assemblies and applying those mechanism connections. Then the next step in the workflow is to access mechanism, the mechanism application. Once in here, you're going to get the option to apply servo motors. And a servo motor is going to impose a particular motion in your model. You can cause a specific type of motion to occur between 2 bodies in a single degree of freedom. You can apply these servo motors to a motion axis or a geometric entity, such as a plane, the planar surfaces, and also points. You have the motor definition dialog box that will allow you to specify the name, and then it will allow you to specify the type, which is, again, either going to be using an axis or it's going to be using geometric entities. And then you have the profile, which will allow you to specify pretty much what type of motor it's going to be. So you can do velocity, you can do position, you can do acceleration. You can tell it where the initial position is going to be, and then you can specify a magnitude. Right. This could be constant, this could be a function, this could be driven by a table. So you get a lot of flexibility as far as how you want to drive that magnitude. In the example here, we're just showing a constant magnitude with a value of 6 millimeters per second. Okay, so that's going to be your servo motor definition. Once you got your motors applied into your mechanism, then you can run an analysis. There are different types of analysis that you can select. You have a position analysis, which is pretty much just testing your your mechanism, right? See if it works, see if everything moves fine. Then you have a kinematic analysis, which is going to evaluate the motion of your mechanism as driven by servo motors. Then we have the dynamic analysis, which is the relationship between the forces acting on a body, the mass of the body, and the motion of that body. Then we have a static analysis that will determine the state of a mechanism when it's subject to known forces. And then we have a force balance analysis. And this one is kind of the inverse of a static analysis. You derive the result reaction forces from specific static configuration. So in the static analysis, you apply the forces. On this one, actually, your result will be the forces. So think of a one of those toolboxes that you put on the back of a truck, and you know, you got the cover for that one, and you got a piston holding it down, right? Maybe you want to find out how much force you need in order for that piston to actually fully disengage, right, and allow the cover to open fully. That's something that you can do with the force balance. And then, of course, you have your analysis definition dialog box, where you choose you specify the name, you choose the type of analysis, how long do you want this analysis to run for. If you wanted to start the current position, or if you have a specific snapshot that you want to use, and then your servo motors, right? If you have multiple servo motors, do you want the servo motors to go from start to end? In this case, we have two motors that both of them act at the same time all the way through the analysis. But I can actually have them so that one motor goes from the start to, I don't know, 25 seconds. And then the second motor will kick in at 25 seconds, and then it'll go all the way to the end. So you can actually activate the motors at different times during your analysis. So that's how you configure your motors. And once you run your analysis, then you can do a playback on it. So you can actually see the animation on it. You can play around with the speed of it. You can specify the image size when you export this animation. And I actually put this video here. It's really short and it's actually pretty light. But you're going to be able to see the mechanism that we're actually going to work on in the demo. And that's you know, pretty much exported from there. And you can see how, you know, it is running pretty slow right now, but you're going to be able to see it a little bit better when we go over the demo. So that's you know, that's our mechanism. That's the one we're going to work on here just in a minute or so. So let me jump into into Creo Parametric, and here we're going to start by first creating our assembly. So we're going to click, you know, we're going to follow the same procedure as we usually do for the assembly. And we just select the type of connection that we want to apply. The system already knows the references that it's looking for, and all we got to do is just go in and specify those references. So we define our references, and then we complete the placement for our component. Then we're going to bring in the bucket. Again, the assembly we're working with is going to be a loader. So it's going to be the bucket of a loader. We do the same thing again. We just specify our references, and we complete our placement right here. Now we're going to bring in the two pistons that are actually the ones that are going to drive this mechanism. So these are you know, pretty important in our mechanism. So we bring them in. We're going to start by locating the component, and then we specify our connection. So for this one, notice that what we're going to do, we're going to start by specifying a pin connection right here at the bottom. And then this same component has to be connected to the arm. So what we do in cases like this, we actually go in and we specify a new set. This time, we don't want to over-constrain the mechanism. And one of the connections that we talked about was the cylinder connection. That's the one that will allow you to rotate around an axis, but it's not going to constrain translation, because we already have translation constraint with the first pin connection, so we don't need to over-constrain it over here. So that's the one that we're going to use in this case here. Then we bring in the second one. So we go over the second piston. And we start creating our connection. So we do the same procedure again, and you can see that this mechanism is actually pretty simple. Again, we don't have a whole lot of time to go over a more complex mechanism here, but that's the one we're going to be using. And then we use the next set, and we change this one to a cylinder type, and we just simply connect this one over here. So now that we have our mechanism fully defined, we complete it, and then let me go into the front view so we can see this a little bit better right there. What we're going to do at this point, we're going to access our applications tab. Then we're going to use the mechanism application right here. This is the one that gives you the set of tools that we're talking about: servo motors, running analysis, dragging the components around, creating snapshots. You can do all this from here. So what we want to do first, this will allow me to check if my mechanism connections are correct. And all this is going to make sure is that nothing is conflicting, that my mechanism can actually move freely. Once we go over that, then we're going to start by limiting or setting the starting points for our components. So we go into our connections. So notice how you get a mechanism tree right here. This will give you your joint connections, and then we can look at the translation reference for each one of our two pistons, and we can actually do an edit definition on it, and we can tell it, what, right now I got a minimum limit of 80, a maximum limit of 425. That's a slider connection that the piston has, and that's how far we're limiting, or the distance that we're limiting between our references. If I try to set an initial position here to 50, it's not going to allow me, because my minimum limit is going to be 80. So I can type an 80 right here, and I can make this my regeneration value, so that when I regenerate my assembly, it goes automatically into that 80 distance that we're going to be using. And then we're going to do the same thing on our second piston. And this one, we're just going to specify a 350 initial position on it. So now that we have our initial position set up, then we got to go in and we got to start applying our motors. So the first one that we're going to use is going to be this connection right here. So we have a slider connection right there. So when we select it, we right click and we can apply a servo motor to it. Actually, hold on. That's going to be this one here. So we do the servo motor to it. It's going to be a motion axis. Then we go into our profile tab. We specify velocity. This one is going to have a velocity of 6 millimeters per second. Okay, that's the the one we want to use. So that's going to be our first motor. We specify that one there. Then we go into our second motor, which is going to be this one right here. What we do into this second one, we're going to apply the same way. We change it to a velocity. But this time, instead of having a constant magnitude, what we're going to do, we're going to change it to a parabolic. And let me specify the value, and we can actually see the graph and how this motor is going to behave. So we graph it. That's how our motor is going to behave with respect to time. So that's our velocity with respect to time. And that's pretty much what we need on this one. we want to flip the so that it pulls in. So we want this motor to be, or this piston to be pulled in. So that's the arrow that you see right here. So once we have this, the next thing that the mechanism will allow you to do is actually apply a measure. So I'm going to apply a measure right in this vertex right there. So we want to do a position, and we want to see how far the displacement of that vertex is at our maximum. So how much of a displacement we have exactly on that vertex. And we can click OK from there. And that's going to be the measure that we're going to be applying. So once we do that, then we go into our analysis. So mechanism analysis. On here, what we're going to do is we're going to run a kinematic analysis. And we're going to run it for 50 seconds. We start at the current position here. And all we got to do simply is just run our analysis. And we're going to be able to see how our mechanism is going to behave. And that's the analysis that we have. At that point, we can actually analyze our measure. So we go over here and we click on this measure right there. We can actually see the result on it, which is a value that we have, and that's going to be our maximum displacement that we have over this vertex right there. And that's, again, just something that you can do within your analysis as well. The last thing that we're going to see is going to be a playback. So I can actually replay this mechanism, and I can play a little bit with the speed. I'm going to put it to the highest that we have right there. And we can just simply replay this one. Also, the capture button right here is the one that will allow you to export this as an MPEG or an AVI, so you can have a video format and you can actually specify the size that you want. So you specify the name, you specify the image size that you want to use, and you specify the frame rate that you want to use for your animation, and then it'll export it as your format, and that's going to be your mechanism. So at this point, let me see if we got any questions. Give me 1 second here. Let me see if I can. You guys are asking me how to put snapshots in a drawing. Okay, so that's a great question. So let me go. I'm going to exit out of mechanism mode, and I'm going to use this drag components. I'm going to expand this right here. And what you want to do is you want to drag the components to a location where you want, right? Let's say I want to create a snapshot right there. I'll click on this button right here. That will give me a snapshot 1. And this icon that you see in this dialog box is the one that will allow you to use this snapshot in a drawing. So once we have this set up, now we use it in a drawing. And really quick, since I don't think right now we have any, doesn't look like we have any other questions, I'll create a quick drawing for you. Just to drawing. Over the front view, and under the view states, it'll treat it as an exploded view. So notice that we have snapshot 1. That's where you actually go in and choose the snapshots that you want to have for that component. So that's going to be listed under the explode view. For some reason that's where it's going to be. So that's again, mechanisms is a really broad topic. There's a lot to mechanisms. It's just a brief introduction, how to use connections, how to take this a step farther, how to automate your mechanism, how to run analysis on them. So we still have a couple more minutes for any questions. So if you guys have any questions, feel free to type them in, and then I'll go in and answer those questions. Let's see what else we got here. So I got one question here on a spring that's you're trying to deform it. It is possible doing Creo, however, that's it would take me quite a bit of time to show you how to do that. So I'll keep your name here, and I'll get back to you on that question, on that mechanism. Okay, so the translation values when defining the piston is another one of the questions that I have here. So when you actually create, so I'm going to open the piston by itself here. So when this cylinder was assembled, right there, actually we have a slider connection that uses two planar references. These planar references are the ones that will be used in order to give it a distance. So right now, it doesn't have a limit over here. So we go under translation axis, and this is actually where you specify where your current position is, where your regeneration value is, where you specify your maximum and minimum limits that you're going to be using. So as you apply your slider connection, it's going to have three components on there. It's going to have the axis of alignment, it's going to have the rotation reference, and it's going to have the translation axis, which is the one that will allow you to specify that distance. It says, what type of definitions do you have to set in the cylinders before assembling them? It's really no difference from a regular assembly. All you do is just specify the connection type that you're going to be using in that case. Okay, so that's again some of the questions that we have here. I believe that's those are all the questions. I hope I answered your questions. If if there's something else that I'm missing, you can always contact me. With any questions that you have. And I'll be more than happy to help you guys out. With anything that you guys have on Creo Parametric. Also, I just want to mention you guys that we do have virtual training. So if you guys are interested in any type of training, now we're offering virtual training, which means that you connect via GoToMeeting, same way you're doing it right now. The benefit of this is that you guys can actually share your screen with the instructor. So you'll have the instructor available, and you'll follow the class the same way you would do with a on-site training, except you're sitting at your desk, and you have a lot of flexibility that way. So just if you guys are interested in that, we do have now virtual training here at TriStar. So if there are no other questions, again, I want to thank all of you for attending this webinar, and hope you got something out of this webinar, and let me know if you have any questions. Thanks so much.